Hello everyone. In continuation of the previous lecture in airport engineering, we discussed about what is runway and how runway is oriented and what are all the basic preliminary information we required, like preliminary information, crosswind component, headwind component, all those things that we have discussed. In this lecture, we'll talk about wind-rose diagram, which is specifically used to orient the runway. Windrose diagram. The graphical representation of direction, duration, and intensity of wind obtained from wind data is called windrose diagram. Wind data will be usually collected for at least 5 years, preferably 10 years. Windrose diagram helps in analyzing the wind data and obtaining the most suitable direction of the runway. So what you are seeing is a typical windrose diagram. You could see the concentric circles and the radial lines which will show the directions and duration and various intensities of the wind data depicted in the picture. And what you are seeing in this slide is windrose type 1 diagram. You could see the radial lines shows the wind direction north, east, south and west, and the concentric circles shows the duration of the wind. So, windrose type 1 diagram, the one which you have seen in the prior slide, is a 360-degree circular curve. It is divided into 16 parts of 22.5 degree each. The directions are from north, south, east and it goes up to west, south, west. Each circle represents the duration of wind to a certain scale. The deviation can be sometimes taken as 33 degree. Windrose diagram. There are basically two types as we have discussed. Type 1, it will show only the direction and duration of the wind, whereas type 2 windrose diagram will show direction, duration and along with that intensity of wind will be also shown in the type 2 windrose diagram. Now we will discuss about type 1, which shows only the direction and duration of the wind, which we have seen already. The radial lines in windrose diagram indicate the wind direction and each concentric circle represents the duration of wind in some scale. From the wind data which we are going to see in the coming slide, it will be observed that the total percentage of time in a year during which the wind blows from north direction is 10.3 percentage. So likewise, we'll plot the values of duration of all the directions in the respective directions and concentric circles. Similarly, other values are also plotted along the respective directions, and then all plotted points are then joined by straight lines. The best direction of runway usually along the direction of the longest line coming from the windrose diagram which we created using the wind data. In the coming figure you could see the best orientation of runway is in north-south direction. Windrose diagram. The graphical representation of direction, duration and intensity of wind obtained from wind data is called windrose diagram. Wind data will be usually collected for at least 5 years, preferably 10 years. Windrose diagram helps in analyzing the wind data and obtaining the most suitable direction of the runway. So this is the final plot of the data shown in our windrose diagram type 1. You could see the direction of line, those are all the radial lines of all the 16 directions, and the total duration is plotted along the respective directions. The longest comes out to be the north and south direction. So it is best possible to orient the runway along the longest line after connecting all the points. So you could clearly see in this drawing north-south direction is having the longest line from this windrose diagram type 1. So it is better to orient the runway in the north-south direction. So this is how we will orient the runway using windrose type 1 diagram for any runway. Hello everyone. In continuation of the previous lecture in airport engineering, we discussed about what is runway and how runway is oriented and what are all the basic preliminary information we required, like preliminary information, crosswind component, headwind component, all those things that we have discussed. In this lecture, we'll talk about windrose diagram, which is specifically used to orient the runway. So this is your windrose diagram type 2. You could see the radial lines and concentric circles are plotted to some scale, and along with that the intensity of wind is also plotted to some scale in each segment. For example, 15, 25, 35, like that along north direction. And you could see the next drawing, equally spaced parallel lines on a transparent strip. You could see the nearby parallel lines is having a magnitude of 15 miles per hour. So that is our permissible crosswind component. So we have to use this strip and we have to place it on the windrose diagram type 2, and we have to rotate in such a manner we'll get the best possible orientation of the runway. So this is your typical wing data and the windrose diagram type 2, and you could see the transparent paper is placed on the windrose diagram and it was oriented in a such a way that the north south direction gives the best orientation for this runway. So if you sum all the segments 0.1, 0.02, 0.10, 0.75, which covers between the equispaced parallel lines, and that comes out to be the longer, and we have to orient our runway in that best possible direction. So this is one more picture depicting the windrose diagram type 2. Here they have used the crosswind component as 15 km per hour. So here we have got the orientation along east-west direction. It means the values summing up from the equispaced parallel lines is coming higher for east-west direction. Change in the direction of the runway. The ideal orientation decided from the study of windrose diagram may have to be slightly altered or even changed because of the following factors: excessive grading, noise nuisance, and obstruction. In case of excessive grading, the runway orientation may need alteration due to excessive grading and earthwork, even if the orientation from the windrose diagram is satisfactory. Noise nuisance. If the runway orientation is along the direction where places of developed residential areas and places of public assembly etc. falls within the takeoff or landing path, then it is desirable to alter the orientation. Obstructions. For layout of runway, obstruction-free approaches are much more essential than crosswind component. Hence, if orientation is such that provides more obstructions, although it has greater wind coverage, it is desirable to change such orientation. So in this lecture, we talked about how to plot a WINDROSE diagram of both type 1 and type 2. The type 1 shows the direction and duration of the wind, and type 2 shows direction, duration, and along with that intensity of wind is plotted. So using WINDROSE diagram, it is easy to orient your runway.